Now let's talk about receiver side. Okay, so let's talk about um, receiver. Okay, so on the receiver side, things looks like this again, and the default status is high. Okay, if data is if this line goes low, that means transmission starts, so it's a start bit. Okay, and then let's say we have data bits like this, and one, so like that, and then goes low here, and then high, and then low. It's low, high, low, high. You know, it can be different, but again, and so finally like this. Okay, so this is the start bit. Okay, and at this point it resets its timer, and then then it reads the values, right? So but it doesn't read the value here or here, it reads the value in the middle. Okay, so based on the duration set for the communication, right? So let me clear these two things. And so reading happens in the middle, because that's like if there's I mean, nothing is perfect, so like if you read in the edges, like here or here, like in the edges here or edges here, like there might be small delays. None of the clocks are perfect, so it might be, so it's better to read in the middle. Like a duration is basically, sorry, the duration is then is from here to here, right? And then another duration from here to here. So you read here, and then you read here, and then you read here, and same, right? So, and finally like that. So that's the receiving end of the things. Okay. Here, a few things. If the receiver samples too slow, like the receiver and like a transmitter and receiver clocks should match. I mean, they don't have to be synchronous. Like this is asynchronous communication, but like for like a duration for every bit has to be fixed for both sides, and they have to be like very close. Okay, so they have to be very close for both transmitting and receiver side. So if receiver samples too quickly, what happens? This is data coming like this, right? So if you sample too quickly, what's gonna happen? So you might sample more than one time for a bit, right? So if it is too quickly, if the receiver samples too quickly, so instead of sampling once here, so you can sample maybe here and then another one here, and then you might sample twice, right? So that's why if receiver samples too quickly, then so then so too quickly, then may sample more than one for a bit. Okay, so if on the other hand if receiver samples too slowly, then obviously what's going to happen if it is sampling too slowly, like let's say samples here and then samples here, it's like duration for the sample is long, then it can skip this one, right? So it's gonna skip this one. So that's a problem. So we don't want to have that too slowly. Then in that case may skip some bits. Okay. So then let me have this one. So these are few important things about the receiver side. So sampling too quickly or too slowly is gonna be an issue. Another thing is the receiver verifies that parity bit is correct. Okay. Okay. So basically, if on the receiver side, when receiver gets the data, it checks the parity bit, and like based on the parity bit, if it is, let's say, if it is even parity, and if the total number of ones are even and parity bit is odd, then that means something wrong during the transmission, right? If you are using even parity, then total number of ones, if total number of ones in the transmission is even, then the data bit has to be zero, right? And if total number of ones are odd, then the parity bit has to be total parity bit has to be 1. So as we explained, so check by like your receiver side checks that, and if there is some if they are not matching, if the data is not obeying the way we the rule for the the even parity or odd parity, so then that means something happened during the transmission. That can be due to many things. We have a lot of noise around us, electromagnetic waves and things like that. There might be other things. So and if there's an error in the transmission, then what happens is basically receiver does not accept that data and just trashes it, and then waits for new data coming in. Okay. And let's talk a little bit more about transmission speed. Okay, transmission rate. So in UART we call it baud rate. Okay, so baud rate. Okay, so that's called baud rate in So it's called baud rate. Again, if we say the speed of transmission is 1200 bit per second, that means it's 1200 baud. Okay, that's how we name it. Or another name, like a bit like 1200 hertz, right? So they are all same thing. So if somebody says like a transmission rate is 1200 hertz or 1200 bit per second or 1200 baud, they are all same thing. Okay, so let's do an example very quick. If transmission speed is, let's say, 9600 baud, that means duration. Let me correct this one. So duration of each bit is going to be obviously equal to 1 over 9600, like we did before. So it's gonna be 104 104 microsecond. I mean 104.17 something, I guess, microsecond. Okay, so again, just to remind you that baud rate is predetermined on both sides. So both sides has to have the same baud rate or very, very, very close. Otherwise, the things that we mentioned above is going to happen. So if it is, if the receiver baud rate is, like faster, higher than transmitter, then it's going to sample more than then it's that means it's going to sample one bit more than one time. Okay, so basically it's going to be the receiving end is going to get the wrong intelligence. So on the receive, again, same thing. If it is too slow, then the receiver side, if receiver side is too slow, then it might skip, because of the slow sampling, it might skip some bits, right? So that's why they have to be, the both side, transmitter and receiver side, should have same or very, very close baud rates. Okay, so now let's talk about UART registers in PIC24.